Artificial intelligence feels intangible. It lives on screens, inside apps, and behind cloud-based services that respond instantly to our requests. To most people, AI is software, lines of code, algorithms, and digital intelligence that seem detached from the physical world. But AI has a hidden, material footprint. Behind every chatbot answer, image generator, automated recommendation, and enterprise AI system lies a vast network of physical infrastructure, data centers. These facilities power the modern digital economy, and as AI expands across the United States, so does their scale, intensity, and resource consumption. Among those resources, one stands out as both critical and increasingly scarce: water. While electricity used by AI data centers has begun to attract public attention, water consumption remains largely invisible. Yet it may become one of the most serious environmental and social challenges tied to America's AI boom. This is the story of how AI data centers use water, why the demand is growing so rapidly, and why many communities are only now realizing what it means. What is an AI data center? At its core, a data center is a facility that houses servers, powerful computers designed to process, store, and transmit data. Traditional data centers have existed for decades, supporting websites, email, and cloud storage. But AI data centers represent a new generation of infrastructure. AI workloads are fundamentally different. Training and running large AI models requires massive computational power, high-density server racks, continuous, uninterrupted operation, extreme cooling capacity. Modern AI chips consume far more power than traditional servers. That power turns into heat, and heat, if not removed efficiently, will damage equipment and shut systems down. Cooling is not optional, it is essential. This is where water enters the picture. Why water is central to AI cooling? Cooling high-density servers with air alone is often inefficient and energy-intensive. As AI systems grow larger and more powerful, many operators turn to water-based cooling because water absorbs heat far more effectively than air. There are several ways water is used in AI data centers. 1. Evaporative cooling. Many facilities rely on evaporative cooling towers. Water absorbs heat from the system and evaporates into the atmosphere, lowering the temperature of the remaining water. This process is efficient, but it consumes water continuously. 2. Chilled water systems. In these systems, water is chilled and circulated through pipes near servers, carrying heat away. Some water may be recycled, but losses still occur due to evaporation and system inefficiencies. 3. Indirect water use via electricity. Perhaps the least visible form of water consumption comes from electricity generation. Many power plants, especially thermal plants, use vast amounts of water for cooling. When a data center increases electricity demand, it indirectly increases water use at power stations. Taken together, these systems mean that AI data centers use water both on-site and off-site, often at levels that rival entire municipalities. How much water are we talking about? Precise numbers are difficult to obtain because water usage data is rarely disclosed publicly. However, available studies and reporting suggest that a single large data center can consume millions of gallons of water per day. Some facilities use water at rates comparable to small or mid-sized cities. AI-specific data centers tend to be more water-intensive than traditional cloud facilities due to higher heat density. Unlike residential or agricultural water use, this consumption is largely invisible to the public. There are no sprinklers running, no visible runoff, no smokestacks, just quiet buildings behind fences. Where America's AI data centers are being built. Geography plays a crucial role in this crisis. Many AI data centers are concentrated in regions that already face water stress or growing demand. Northern Virginia, one of the world's largest data center hubs. Arizona, a desert state with chronic water shortages. Texas, rapid population growth and frequent droughts. Midwestern states, attracted by cheap land and power. These locations are chosen for practical reasons: access to electricity, proximity to major internet hubs, tax incentives, and available land. Water availability, however, is often treated as a secondary consideration, or assumed to be sufficient until it isn't. In some cases, data centers draw water from the same aquifers and municipal systems used by residents, farmers, and local businesses. Why the water crisis remains largely invisible. One of the most troubling aspects of this issue is how little public awareness exists. Lack of transparency. Data center operators frequently classify water usage as proprietary information. Unlike factories or utilities, they are often not required to publicly report detailed consumption figures. Quiet operations. Data centers do not look like industrial polluters. They don't produce smoke or strong odors. From the outside, they resemble office parks or warehouses. Fragmented regulation. There is no unified federal standard governing water use by data centers. Oversight is handled at the local or state level, often without specific rules tailored to AI infrastructure. As a result, communities may not understand the scale of water usage until shortages, restrictions, or infrastructure strain become visible. The local cost of a global industry. AI companies operate globally, but water is inherently local. When a data center consumes large volumes of water, the impact is felt most acutely by nearby communities. In some areas, residents report increased water bills, reduced water pressure, seasonal restrictions on residential use, greater competition for agricultural irrigation. Municipalities may invest public funds to expand water infrastructure specifically to support data centers, effectively subsidizing private AI growth with public resources. This raises difficult questions about fairness and priorities, especially during periods of drought. Climate change and compounding risk. Climate change intensifies the problem. Rising temperatures increase cooling demands, meaning data centers require even more water during heat waves, the same times when water supplies are already strained. At the same time, changing precipitation patterns are making droughts more frequent and severe across much of the United States. This creates a feedback loop. Hotter climate, more cooling, more water use. Less water availability, higher competition and risk. Without intervention, this dynamic could make some regions unsustainable for large-scale AI infrastructure. The AI arms race and resource pressure. Another driver of the crisis is competition. The AI industry is in a race for dominance. Companies are under pressure to build larger models, deploy more data centers, reduce latency and increase capacity. In this environment, sustainability measures often come second to speed and scale. Water-efficient designs, closed-loop systems, and alternative cooling methods exist, but they are more expensive and slower to deploy. When market incentives reward rapid expansion, environmental efficiency becomes optional unless mandated. Are there solutions? The water crisis tied to AI data centers is not inevitable. Several solutions are available, though each comes with trade-offs. 1. Closed-loop cooling. These systems recycle water more effectively, reducing overall consumption. They require higher upfront investment but significantly lower long-term impact. 2. Use of reclaimed or non-potable water. Some facilities can operate using treated wastewater instead of fresh drinking water, reducing competition with residential supply. 3. Geographic optimization. Building data centers in cooler climates or water-rich regions can reduce cooling needs, though this may increase transmission distances. 4. Transparency and reporting. Mandatory water usage disclosure would allow communities to make informed decisions and plan infrastructure accordingly. 5. Policy and regulation. Clear standards for water efficiency, similar to energy efficiency rules, could reshape incentives across the industry. The challenge is not technical feasibility, it is political and economic will. Why this issue matters now? AI is still expanding. The largest wave of infrastructure growth may still be ahead. Decisions made today, about where data centers are built, how they are cooled, and how water use is governed, will shape resource availability for decades. Water scarcity is not a future problem. In many parts of the United States, it is already a present reality. Ignoring AI's water footprint risks turning a technological success story into a long-term environmental liability. The hidden cost of intelligence. Artificial intelligence promises efficiency, productivity, and innovation. But intelligence is not free. It consumes power. It consumes land. And increasingly, it consumes water. Because that cost is hidden, spread across pipes, cooling towers, and distant power plants, it is easy to ignore. Yet for communities living near AI data centers, the impact is tangible and immediate. The real question is not whether AI should exist or expand. It is whether society is willing to confront the full cost of that expansion honestly and transparently. Because the future of intelligence may depend not just on data and algorithms, but on one of the most basic resources of all, water.